Hey there. So I want to talk about measurement and units, and I this is a PowerPoint that I made really back in the day. I used to instruct a physics class for a after-school program, but I altered it so I can do a lot of work on not with the PowerPoint, but on my little writing pad. Anyways, let's start. So that's some units. So for units, we are going to talk about volumes, length, energy, temperatures, and time. And we have several units for these quantities. We have for volume, that's liters, gallons, ounces, and so on. And then we have length with ounces at the time, but I wasn't sure whether that was a unit of volume. It is. It can also be unit of mass. It really depends on the density of what you're taking the mass of. For length, there's meters, yards, miles, and light years. Light years, sometimes people think it's a measurement of distance, but really that's the distance light can travel within a year, so it's length. Then we have energy. We have joules, electrovolts, calories. For temperature, we have Celsius, Fahrenheit, and Kelvin. And time, we have seconds, minutes, hours, days, and so on. Now with units, we have so many of them, so we just care for a unit that we use universally. One unit that, for instance, for distance all around the world, if you want to do calculations, we have the one thing that we have in common is meters. So that's the SI unit for distance, and then the SI unit for volume is meters cubed, Kelvin for temperature, seconds for time, radians for angles, kilograms for mass, and joules for energy. Now, if you're one of my students, you probably have your notebook out and you're really writing these down. But when you do write them down, when you write meters cubed, don't write it like this. It's probably not very difficult for a lot of people. But that was computer notation. I want you to write meters and then cubed. I mean, just to make sure. Anyways, so we also have joules for energy. That's what I already said it. So we're going to talk about prefixes, and here's why. For the SI unit prefixes, the nice thing is that the base is we're in the base 10 system, or mode 10, meaning that we go from 0 all the way to 10, and then we start our numbers over again, 11 to 20, and then 21, 22, 23, 31, 32, 33, and then all the way up to, we pretty much to go from one, what do you call it? Sometimes I will lack what it says, but place value, to go from one place value to the next one is pretty much a distance of 10. So that's why we have the ones, the tens, the hundreds, the thousands, the 10,000s, and then from the other point of the decimal we have the tenth, and so on. Anyways, so we have these example of numbers. So for instance, the speed of light is roughly 300 million meters per second, and if you look at the wavelength of red light, that's roughly 0.000000650 meters, right? Now I should have just said 65 meters, not 650 meters, because that would indicate that I'm pretty sure it's 650, that this is 650, but I should have just left it at 65. That we're gonna talk about significant figures later. Anyways, these numbers are way too big and we want to make them look nicer, and the way we make them look nicer is to use prefixes. So let's go to our speed of light. So let's talk about the speed of light. By the way, if you were my student, you didn't have to write this down. This was just something I told you. But if you do the example with the speed of light, you do have to write this down. You have 300 million, but the problem is we don't want to have to write this down all the time. So sometimes we can use a prefix. So instead of saying 300 million meters, we can say 300, and we can write megameter. What mega implies is 10 to the 6. If we go back to our table, you can kind of see that 10 to the 6, which is mega, is right here. The symbol is big M. So the big M implied meters. And then when we had the for light, it was 0.00000. I think there were 6 zeros behind the decimal. 1, 2, 3, yeah. 650, and then there was a 0 here. Meters. That's how long the wave of red light is. The wavelength. So to kind of make this number look nicer, I'm gonna have to kind of figure out what to do with this. So how many times did I go? Let's see. It was 1, 2, 3, 4, 5, 6, 7, 8, 9. Now to kind of make the decimal go all the way around right here, I would have to multiply this number by 10 to the 9, because 10 to the 1 would move it here, 10 to the 2 would move it here, 3, 4, 5, 6, 7, 8, 9. So instead of saying this, I can call it 650 nanometers. Now I know that I said that I would have to multiply by 10 to the 9 to get it to right here, but the thing is, the trick is, once I do multiply by 10, I need to make sure people still know that this was originally a small number, so we use the word nano. So 650 is a big number, but once you attach this 650 meters, but once you attach this n right in front of it, we're saying nanometers, so people know that this is really 650 times 10 to the negative 9, which brings it right back to this meters. It's just we don't want to have to write this all the time, and you might be a scientist and you're in the lab where you worry about light frequencies and wavelengths all the time. You want to say nice numbers. You want to say 650 nanometers. You don't want to every time say, oh yeah, the wavelength we discovered today was 0.000000650 meters. It just isn't fun, and it can be annoying at some point. So that's why we use prefixes. So prefixes are really nice when you're trying to figure out how to deal with these huge numbers or these really small numbers. So here's some examples. So what I would like you to do is kind of pause the video and do them yourself. So I suppose you paused the video and you tried these using the table that you probably copied from the previous slide if you were one of my students. So now we have to worry about these numbers. Let's go with the first one, 300 meters. This one is a pretty common one. People have dealt with this before. Would you like to save? No, I do. So 3,000 meters. Well, let's go back up. Press the button on my pen that I shouldn't have pressed. Okay. 3,000 meters. Now this one you've dealt with before. You probably heard of kilometers. This is 3,000. This is 3 kilometers because kilo implies 10 to the 3, which is 3 times 1,000, and 3 times 1,000 is 3,000 meters. If you want a trick to it, you just count the zeros, and if every time you get a pair of 3 zeros, you kind of try to use the SI unit. This is 3 zeros, so I use kilometers. And it doesn't have to be a pair of 3 either. It can be let's see, let's go back to this. It doesn't have to be a pair of 3 either, because you can see that these prefixes can also take care of pair of 2s or pair of 1s. You can have decameter if it's 10 meters. And then anyways, but once after you get past the first and the second one, we usually do pairs of 3s. So you can see how it goes from 3, 6, and 9. Alrighty, and then we have this guy. We have point, and then we have 3, 6, 7 zeros after the decimal point, and then joules, 5 joules. So let's see how to deal with that. So we have point 1, 2, 3, 4, 5, 6, 7, 5 joules. So 0.000005 joules. So in order to make this look kind of nice, you go 3, 4, 5, 6, 7, 8. I don't have a prefix for 10 to the negative 8, so we are gonna have to go 10 to the negative 9, because if you look at your table, we got 10 to the negative 9 being nano. So since we had to go one decimal beyond the 5, we just kind of put an imaginary 0 here. So really, you can call this 50, and then to go 50 all the way back to where you originally were, you go 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 50 nanojoules. So 50 nanojoules, and then and then 7 zeros and 5 joules is virtually it's the same thing. So that makes that number look a lot better. Let's go ahead and refresh the page. New. Do not save it, and let's go back. Alrighty, so the next example is 0.006 liters. That's well, you're not writing anything. 0.000. Was it 3 zeros? Yeah, 6 liters. Moving it once, twice, or 3 times will not do the trick. We need to move it. So 3 times did not do the trick. We need to move it 6 times. You can see that we need to move it 6 times because that's the next prefix that we know. So 1, 2, 3. So this we're gonna have to put 2 imaginary zeros, put the L there, and then we have 600. What do you call this? Exactly, microliters. This is the first time I've really used microliters. I don't think you would ever use it in any other case. Anyways, so now we have that many miles. Again, these are not SI units. Liters is not an SI unit, common misconception. A lot of people think that's the SI units. We do use it in chemistry because 1 mole I think is equal to 22.4 liters when it's an STP conditions, standard temperature and pressure. Anyways, then we have these miles. We have 1, 2, 3, 4, 5, 6 zeros in front of the 4. So 0.000004 miles. And then to make this look nicer without having to use a different unit for distance, we just go well, I really need to learn not to push that button. 1, 2, 3, 4, 5, 6. Missed the mark. We can say it's 0.4 micromiles, but that's still not nice. You want to have a nice number, but you don't want decimals. So 1, 2, 3, another pair of 3. So that's 400 because imaginary zeros. 400, and then after micro, before micro, if you look at the table, was nano. So that's 400 nanomiles. I should have come up with better examples when I made this presentation, because all of them ended up being nano. Anyways, this little n for nano. Let me start a new page because it looks terrible. Do you want to save? No, I do not. Let's go back to our presentation. Anyways, so we have prefixes. We still have 70 million gallons to go. So 70 million. Let's see, 70. 1, 2, 3, 2, 3. Oh, this looks terrible. I need to get better at this. Okay, and then gallons. Good thing that you guys are at home taking notes with your pencil. You guys can do a better job. Alrighty, so using prefixes, I can go deca. No, wait a second. Deca was the other one. Sorry. Let's fix that right away before I continue. Yeah, it was deca. Okay. So it's deca and then hecto. Alrighty. So I could have said, I could have gone just 1 and say that this thing is 7 million. Let's see, that's 7 million decagallons, and decas with a little d, was it? Or was it? no, symbol is dA. I could have said decagallons, but we can still do a better job. So I can go deca, I can do hecto, I can go kilo, and then I go another 3 to make it mega. So it looks like mega is good, because if I went too far, then I would end up with a decimal. I don't want that. So I can call it 70 megagallons. Megagallons. Kind of like Mega Man, but we're talking about gallons, so megagallons. So it's nice. So you can, I guess saying 70 million gallons sounds better than megagallons, but writing wise it reduces your how much you have to write. Alrighty, and then that's for the examples of that for you. Now we're going to talk about unit conversions, and what you see here right now, you see a given unit. You may be given something and you want to turn it into a different unit. This says if you've taken chemistry and you've done stoichiometry, you're really good at this. But the whole idea is you can sometimes you'll take a physics exam, and you may let's say you have a test right in front of you, and then they're saying that okay, so this person is traveling 70 meters per second, and then it's this person has gone for 30 seconds, right? And you kind of don't know what to, and let's say you don't know that velocity times time is distance, but you look at your little choices A, B, C, D, and like A is saying 210 meters, and you kind of can tell that, hey, if I multiply these two numbers together, look at the units. You have meters per second, and then you're multiplying by seconds, which is the same thing as seconds over 1. You can tell that for the units wise, the seconds cancel out, and you're left with meters, which is the unit that we have here. Also, when you multiply these two numbers together, you do get 210. So this ends up being a distance, and then they're also going to ask you what the distance is you traveled. So you kind of can tell without looking. But you can make a really good argument that this is the correct answer, assuming that all the other ones don't have meters after them. So that's like the most simple example for when you can use unit conversions for that. But if you multiply a given unit, and then you have like let's call this unit 1, and then you have something else as unit 1, a known unit, where all these fractions really equal to 1, because you could have miles and you're trying to convert miles into inches. I think there are 5,200 and something inches. You'll pretty much say, okay, this is like 5 miles, and this is 1 mile, and up here we have like 5,000 something inches. And it turns out that, oops, that's supposed to be an animation where it crosses these out, but go back. Alrighty, so go back to this guy right there. Let's make a new screen. Let's say you have unit 1. Well, let's say you have unit 1 times, and then you have some kind of fraction where, like, let's say 1 mile or 1 unit 1 is equivalent to 2 unit 2, right? So since these are the same units, the units cancel, leaving you with the unit that you have right here, and you didn't do anything illegal, because you multiplied it by a fraction that actually has a equals 1, because 2 unit 2 is equivalent to 1 unit 1, so dividing them really gives you 1 because they're the same. So here's an example. So unfortunately I don't know how many inches a mile is, and I don't want to go to Google to look it up. So I'm just going to say, let's say you want to convert 3 kilometers to centimeters. I know for a fact that 1 kilometer is equivalent to 1,000 meters, and I know for a fact that 1 meter is equivalent to 1,000 millimeters. I think I said when I wrote this that I want to turn to meters. If I want to turn to centimeters, I would have written down 100 centimeters, but I'm not sure what I said, so we just assume that I wanted to turn this into millimeters. You can see that the kilometers cancel out, the meters cancel out, you're left with millimeters. So if you multiply these numbers together, 3 times 1,000 times 1,000 divided by 1 divided by 1, you should end up with 3 million millimeters. So that's how the unit conversions really go. And we're gonna have like the example like right here, turn 3 miles into meters, and that's gonna be a pain because I don't know how many. I think 1 kilometer is 1.6 miles. I'm gonna have to verify that. But let's get a new thing right here. Do you want to save your picture? No. Alrighty. Let's say that 1 mile. Well, let me just Google that pretty quick. It's really, Google does things really easy for you. So let's use a new tab and let's type in miles to kilometers. So 1 mile is equivalent to 1.6 kilometers. So, which helps me out a lot. So if I want to turn, what was the question again? Well, if I want to turn 3 miles into meters, so 3 miles, I first want to kind of turn it to kilometers because I know that 1 mile is 1.6 kilometers. And then I also know that 1 kilometer is equivalent to 1,000 meters, which when you do the canceling out method that I just showed, that you would get rid of the kilometers, the miles, you're left with meters. 3 times 1.6 is, I think, 4.8. 4.8 times 1,000 is 4,800 meters. Another quick example, 3 liters into meters cubed. So we have 3 liters into meters cubed. I guess when I made this presentation I was really familiar with the conversions, but now I'm not too sure. Let's see. How many milliliters is centimeter cubed? I think that's 1:1, but I am not too sure. Yeah, there we go. Someone already. Yeah, 1 milliliter is 1 centimeter cubed. Alrighty. So you know that 1 milliliter, and that's gonna be difficult now. Here's the difficulty. You know for sure that 1 liter is 1,000 milliliters, and you know that 1 milliliter, let's see, you know that 1 milliliter is equivalent to 1 centimeter cubed. Now here's the hard part that not all people usually get. Now the next thing, I'm trying to get meters cubed. I know that 100 centimeters is equivalent to 1 meter, but this unit will not cancel out this unit. So what I need to do, I need to take this little guy and put it into the power of 3, which would cause it to be meters cubed and the centimeters cubed. But some people just leave it to be 1 over 100, but really it's 1 over 100 cubed. So what that becomes is 1 cubed meters cubed, and then 100 cubed centimeters cubed, which 100 cubed is, what is on the cube? 100 times 100 times 100, so it's like 1 million. 1 million centimeters cubed. So now you can see how the units will cancel out. You notice that the liters cancel out with this liters, milliliters, milliliters, and then you'll see that centimeters cubed will cancel out centimeters cubed, because we're not using this guy anymore, we're using this in its place. So the only thing we're left with is meters cubed. So you multiply things out. This is 3,000 divided by, so 3 times 1,000 times 1 is just 3,000 times 1 is just 3,000 divided by 1 divided by 1 divided by a million. So 3,000 divided by a million is 3 over 1,000, which is 0.003 meters cubed. Meters cubed. and they want to have in meters cubed. If I want to use a prefix, make it 3 millimeters cubed, but that looks kind of awkward. Yeah, sometimes it looks weird using prefixes, but if you want to have it a nice 3, you would have to put m for milli. So let's see what else I got for you for this video. I'm kind of worried that this video ends up being too long, and I don't want you to sit there for too long to watch me or listen to me. So let's see what else we got. Alrighty, and then we have another one. I guess this one I left the animation by accident, but you can see that you only convert 3 kilometers per minute into meters per second, and you're trying to get rid of units. So if I want to get rid of the kilometers first, I would multiply it by 1,000 meters over a kilometer, because I know that 1 kilometer is 1,000 meters. So you can tell that kilometers are going to cancel out. And then to get rid of the minute, right here, which is down there, I know that 1 minute has 60 seconds. So in order to get this minute to cancel, you need to have a minute on the top, because minute divided by minute cancels out. So you can tell that I left those animations when I made the PowerPoint. You can tell kilometers cancel out, and then you can tell that minutes cancel out, and what you're left with is with meters times 1 over seconds, which is meters per second. If you multiply 3 times 1,000 times 1, divided by 1, divided by 1, divided by 60, gives you 50. So you're left with 50 meters per second. Works every time. You can easily convert a velocity into different units, as long as you also make sure to take care of that unit on the bottom as well, which I did right here. Now, if I want to make it into, if I want to have a different unit of time, I could have done that as well. I just would have to know the relationship. Like if I want to use light years, I would have to figure out how many minutes are in a light year. So I could have had like a billion something minutes over 1 light year, or whatever, however many minutes is in a light year. And then I want to talk about Kelvin pretty quick. Please write all of this down. Kelvin is the absolute scale for temperature. The nice thing about Kelvin is that it does not have any negative values, meaning that nothing can get to zero, below 0. Also, on this planet at least, the lowest temperature we ever gotten, I believe, was 2 Kelvin or something like this. They were able to get to really low temperatures by how did they do that? I read an article about that the other day. Lowest temperature ever achieved. Lowest temperature ever achieved. And you can Google that, and then lowest temperature recorded on Earth. I like how they said on Earth. They have the same way of thinking. Wow, we got really close. We got to 1 times 10 to the negative 10 Kelvin. Anyways, go back to the presentation. So 0 Kelvin is called the absolute zero. Nothing survives at that temperature. Nothing moves at that temperature. And if you kind of want to use an example on how to use Kelvin, the surface of the sun is 60,000 Kelvin, the temperature. The reason why I say surface is because the sun has different temperatures and different layers of it, and the surface one is the one that commonly is talked about. To convert Celsius to Kelvin, you simply add 273. Vice versa, you would subtract 273. In example, 20 plus 273 is 293 Kelvin. So 20 Celsius is 293 Kelvin. And then negative 20 degrees Celsius is 253 Kelvin, because negative 20 plus 273 is 253. Now the difficult one is right here when you try to convert Kelvin to Fahrenheit, because we use this equation 5/9 times whatever Fahrenheit you're trying to convert to Kelvin minus 32. Multiply that first because of PEMDAS. You multiply first. Well, you first do the parenthesis part, this minus that, and then you multiply by 5 divided by 9, and then you add the 273. And here's an example. I hope I didn't have. Oh, okay. I have these animations. So if you wanted to convert 75 Fahrenheit to, and Meryl wants to know what it is in Kelvin before lunch. I used to be funny back in my day. I would put 75 where it says Fahrenheit, subtract 75 and 32 would give you 43, then 43 times 5/9 gives you some number which I should have probably written down. Let me just tell you right now. Well, I can tell that because the answer ends up being this, that this times that was probably 23, right? 23.89. But let me just verify it using calculator. Calculator, where are you? I'm using, I might as well just use a computer when I was actually on my phone right now. I just realized that I have an audience. So all programs and then accessories. You really get to know me really deeply because you get to know what programs I've installed and stuff like that. Anyways, back to the PowerPoint and the calculator. 43 times 5, and then divide that by 9. That gave you 23.89, 8 repeating, and I'm adding this to it. I went with, I guess, 5 significant digits for some reason. And we have a happy smile. We are happy because we converted that to Kelvin. And that's it.